Welcome to this eLearn security training lesson video on traffic sniffing. In this video, we will see how we can sniff traffic across a network by using different tools. TCPdump is one of the most popular network packet analyzers. With its command line interface, users are able to dump traffic on a network in a very efficient way. To start exploring TCPdump, let's first see its manual. Let's open the terminal window and call the manual command for TCPdump. As we can see, there are several available options and multiple examples. For a shorter and more readable version of the options, we can also run TCPdump with the --help parameter. From the results, we can see all the available arguments that we can use. Before starting the real sniffing, let's list the available interfaces we can use. To do this, we call TCPdump, followed by the capital D argument. As we can see, there are many available interfaces. Many people tend to use the any interface, but for the purpose of this video, we will focus our task on a specific interface. During the packet sniffing process, we will visit several websites in order to produce some traffic on the network. Let's see how TCPdump works if we don't specify any argument. As there are several interfaces available on the system, we specify the preferred one with the -I option. As we can see, TCPdump starts collecting traffic from the network interface specified. Keep in mind that TCPdump now works on a promiscuous mode. If we pause the traffic sniffing, we can see the amount of packets that have been captured. If we inspect one of these packets, we can see that TCPdump prints the most important information for each packet sent or received. We can see the packet flags, the length, the source and destination, the timestamps, and more. Also note that the addresses here have been resolved with a DNS. Let's now use TCPdump with a verbose mode on. To do this, we run the previous command, followed by the -v argument. Again, TCPdump collects traffic through the network. If we stop it, we can see the actual differences from the previous scan. Now information such as time to live, ID, and total length are included. Also, in the background, TCPdump performs IP verification, and ICMP header checksum for more reliable results. We previously mentioned that the address of the sniffed packets have been converted to names via DNS. TCPdump allows us to use the -n argument in order to disable this conversion. Let's see what the traffic will look like after adding this argument. As we can see now, the websites or the local host are not resolved. We can indeed see their IP addresses. Sometimes, instead of detailed results, we may need to get a quieter output. For this reason, instead of the verbose option, we can use the quiet option, which can be called with the -q option. In the output, we can see that the results contain less information. That does not mean that the information is not enough, though. Everything relies on what we want to capture. TCPdump offers many filter options. We can filter the intercepted traffic by setting the protocol to inspect a specific port, a host, and so on. For example, in order to review only the traffic between our machine and a website, we can set the host argument followed by an IP or the website. Let's see this example in action. We first start sniffing with TCPdump, and then we specify the host parameter, along with the site we would like to sniff the traffic from. For this example, we use elsefood.com. As we can see, if we try to reload a page other than elsefood.com, no results are retrieved. Let's see what happens if we browse elsefood.com. Back to the terminal, we can see that only the traffic between our machine and the elsefood website has been captured. This technique might be useful when we only need to examine traffic from specific websites. In the same way, we can also specify destination and source hosts. Let's see how we can limit the traffic to display not only the packets that come from our IP address, and that are destined to another host. We have to run TCPdump again and specify two parameters. The first one is src, which indicates the source address, while the second is dst, which tells TCPdump the destination IP. As we can see in TCPdump, we can review the whole communication between the two hosts. Another feature that TCPdump offers is the ability to import filters from a file. Let's see what this means. First, we create a file called filters.txt and add the value port 80 in it. Then we go back in our terminal and run TCPdump with the -F option followed by the filter.txt file name. This option allows us to import a file as a filter during the packet sniffing. In this case, we will only capture the traffic sent or received on port 80. Let's generate some more traffic with our browser to see the filter in action. As we can see, the filter is working and we're capturing only the traffic coming or destined to port 80. Another option that can be useful during our tests is count. This option tells TCPdump to stop capturing packets after reaching the amount of packets specified. We can do this by specifying the -C parameter followed by the number of packets we want to capture. In this case, we'll use 150. We are now going to generate some traffic to speed up the process. As we can see from the final output, after collecting 150 packets, TCPdump quits. Let's now see how we can export and save a packet capture into a file to our local machine. This can be done by adding the -W parameter. Keep in mind that the traffic we will export is not readable from simple text editors, and thus, another option will be used in order to read it again. After capturing some data, let's exit TCPdump. To view the captured traffic, we now run TCPdump -R followed by the file we previously exported. As we can see, here is the captured traffic. TCPdump's power is hidden in the possibility to use it with bash scripts. With TCPdump, we can specify several bash options and programs to run in parallel. Let's see these examples in action. On our example, we will use TCPdump with grep in order to display specific information. We will capture traffic on interface ETH1, and we will grep packets that involve a specific IP, in our case, 192.168.1.1. We can do this with the following command. We just need to pipe the TCPdump command with grep. As we can see, we can only view the packets that match the IP address specified. Keep in mind that grep will look for the specific IP address in the output. This means that we will see all the strings that contain this IP address. For instance, here, we are able to capture packets from either our IP or the router's IP, as they both contain the string specified. We can use grep differently each time. Moreover, as TCPdump gives the ability to execute parallel scripts, you can find other tools that you can run instead of grep. We suggest you find your own patterns and use them with TCPdump in order to maximize the output efficiency. What we've seen here are some basic commands and options we use with TCPdump. It's a powerful tool that you really have to master. Thanks a lot for joining us.